Hi, I'm Tuukka Ahoniemi, an authorized Q trainer from DIGIA. Welcome to this learning video based on material taken from Q Essentials training course. With these videos, we're gonna give you key insights into Qt as well as demonstrate the style of the in-depth training given in the Q Essentials training course, which are classroom based. So each different part of the graphics view has its own local coordinate system. That means the view has its coordinates, the absolute positioning in the screen. The scene inside the view has its own coordinates. And then the items inside the scene are positioned to the scene's coordinates, but inside they again have their own local coordinate system. The items can have child items, and they also have their own local coordinate system. What does this mean? It basically means that every time you write painting operations, you're working with your own local coordinate system. If you create an object that's 100 times 100, your graphical item has the size 100 times 100. You can always assume that the center point of that object will be in 50-50, regardless of however the view has been tuned or how much the item has been rotated. It doesn't matter. You'll just work inside your own local coordinate system. This is what makes it actually rather easy to work with graphics view. You can only concentrate to one part at a time. You don't need to worry on the big picture, like what if I have tuned this that much, then I will need to do calculations for this item. Just forget about those. Focus on the single item and its own local coordinates. So the coordinates are local, and as they are transformed, they are logical coordinates, not necessarily pixels. By default, if you're not applying any transformations, one logical coordinate equals to one pixel. The items can have other items as parents or the scene as their parent, and they will automatically inherit the position and transformation of their parent. This basically means that if you're doing grouped items, you have items that own other items as their children. The child items will follow their parent if you move it or if you do rotations. They inherit the same properties. If you do transformations for an item, it does not affect its local coordinate system. Like I said, you will draw it the same way. You will draw the rectangle the very same way regardless of its rotation. So how to do transformations? You can use the class QTransform if you wish to access the mathematical 3x3 transformation matrix, but yeah, you can do it, or you can directly call scale, rotate, shear, or translate for the ones you want to apply the transformation. So this saves you a lot of time if you're doing some simple transformation. You don't need to worry about the actual mathematical matrices. For rotation, you can also define the axis. Even though it's two-dimensional graphics inside graphics view, by default it's going around the z-axis, which means that it's rotating as is. But you can also have the rotation done along along y or x-axis, which does a projection, a two-dimensional projection of the object. And with this you can do actually quite cool stuff. You can apply transformations for view, for instance, in order to do tubing. Here's an example. Let's have a look. I'll take the transformation matrix here, marked with T, and I'll tell the current transformation matrix to rotate 45 degrees along z-axis, which is a simple rotation. I'll also scale with 150% by both axes. I could have different scale values for x and y axis, but normally they're the same. And finally, I will tell the view to use this transformation matrix as the current transformation. If you're doing scaling or zooming for the view, by default it's done so that the center point of the view remains still. You'll zoom in and out on the center point, around the center point. But if you want to do zooming, for instance, that follows the mouse, that you would zoom in to the position of the mouse, you can modify, you can change the transformation anchor point to anchor under mouse. For items, you have the very same transformation operations. You can use QTransform class and set transform or get it with transform function, or you can call rotate, scale, sear, and translate. I'll show you an example. Here, as an initial situation, I have my yellow view or yellow scene shown inside the graphics view. There's text, hello world, and around that there are actually two rectangles. But now those two rectangles are in the same position, so you can only see the one in the top. So I'd like to rotate the second one. Let's see what sort of a code do I have here. I have the view, the scene, that's using yellow as its background brush. The view is showing the contents of that scene. Then I have two rectangles added to the scene and a QGraphics text item with text hello world. Okay, I will tell rect number 2 to rotate by 15 degrees. Let's see what happens. Okay, it did rotate, but this is interesting. By default, it is rotating over the 0, 0. So if I want to rotate the rectangle around its center point, I will actually need to translate. The translate function changes the center point of the forthcoming transformations and drawing operations also. So for rect 2, I'll call translate. I'll move the origin by 50 along both axes, and then after the rotation I will move it back so that I'm not affecting any forthcoming painting operations. Alright, now it's rotated around the center point of the application. Okay, so that was an individual transformation for the item. But how about for the view? For instance, if I want to do zooming, well, I can call view scale. And let's say I'm zooming out, so the scale factors should be 50%. Yep, that's zooming definitely. Sometimes it might be necessary to get the coordinates of another system, of another coordinate system for an individual item, for instance, that you would need to map these different coordinate systems, or you would need to map coordinates along these different coordinate systems. You have functions to do that. Map from scene, map from item, map to item, map to scene. And you can apply these for single points, for polygons, or paintables. For some items, it's possible that you might not want to apply transformations. For instance, if you have an application that's showing images, and you're zooming out, in and out on those images, and then you have a toolbar there with buttons, I would assume you would not want to zoom the toolbar as well. So for those, you can ignore transformations by setting their flag. I'll show you how to do it. In this example, I had the hello world text now zoomed as well. So I'll tell the text not to do that. I'd like to maintain my hello world as magnificent as it used to be. So I will call set flag for the text, Q graphics item ignores transformations. Let's see. Great. We hope you enjoyed this taster of our Qt Essentials training course. For the full interactive experience, including labs, questions and answers, additional info, I personally recommend you attend the full multi-day training Qt Essentials provided by DIGIA or any of the other Qt training partners. For more information, please check qt.nokia.com. Thanks for watching.